Hello everybody, Assalamualaikum warahmatullahi wabarakatuh. Good morning. Let me introduce myself. My name is Desi Agusinasari. You can call me Desi. I work in Chemical Engineering Program, Universitas Singapura Bangsa Karawang, West Java, Indonesia. I have already joined in here since September 2015 as a lecturer. Nice to meet you all. First, I will say thanks for Segi University, especially Dr. Lin Ni Wei and the teams that I have a chance to be a guest lecturer with Chemical Engineering Program Segi University with topic Adsorption process. I hope I can contribute for 2 until 3 meetings. Okay, let's see the submaterial from the absorption. We can utilize Geankoplis. In here we call Geankoplis book. Okay, here. Transport processes and unit operation. I use the 3rd edition. Maybe the latest edition is 5th. You can download or read from the library. See, Christie Geankoplis, the famous name. The absorption process is chapter 12. In chapter 12, discuss about liquid and fluid-solid separation processes. So we just talk about fluid-solid separation process because liquid is different from the absorption. From the material guest lecturer absorption, we can know about the submaterial, sorbents, ion exchange, chromatograph, equilibrium absorption, kinetic and transport, fixed bed absorption, breakthrough groups, anti-thermal swing absorption. So from the chapter 12 Geankoplis, we know the submaterial, introduction, the absorption process until crystallization theory. But for the fluid solid separation process, we just take 12.1 until 12.4. Introduction to absorption process, bed absorption, design of fixed bed absorption column, ion exchange processes. 12.5 until 12.12 is discussed about liquid separation process. Okay, maybe we just use this book 10 or 15 pages. Here, let's begin about absorption or fluid-solid separation. In 12.1, Introduction to Absorption Processes. the main point the absorption processes is fluid and solid separation processes. Fluid contain gas or liquid stream. Solid separation, solid is solid absorbent. Okay, so gas stream with solid adsorbent, liquid stream with solid adsorbent. This is the main point from the absorption process. Introduction. The absorption process occurs on the solid surface of the absorbent to obtain the X component in gas stream or liquid stream. Component X can be one or more components. We can see picture about the absorption and adsorption. Here, absorption inside, adsorption is on surface. And the application of absorption, here the first beaker glass, there are contain fluid, and then the second beaker glass, fluid plus absorbent, and the third beaker glass, you can see the clear two components, the fluid and the absorbent, and then the last is a clear beaker glass with the fluid. Okay, fluid from the gas or liquid, so there are an example is liquid stream with the solid absorbent, yellow color is the solid absorbent in this picture. Okay, in commercial processes, the absorbent is usually in the form of small particles in a fixed bed. The fluid is passed through the bed and the solid particle absorb component from the fluid, and the fluid is passed through the bed and the solid particle absorb component from the fluid. When the bed is almost saturated, the flow in this bed is stopped and the bed is regenerated thermally or by other methods, so desorption occurs. Absorption working and then regenerate. Okay, from this sentence we know about the absorption material. The absorbed material is thus recovered and the solid absorbent is ready for another cycle of absorption, like the cycle. So gas or liquid stream we call absorbent, and then solid particle we call the absorbent. Okay, a Application of liquid phase absorption is include removal of organic compound from the water or organic solution, color, or various fermentation product from fermenter effluent. Separation include paraffins from aromatic and fructose from glucose using zeolite. Zeolite is absorbent, solid absorbent, like activated carbon, but it is synthetic. Application of gas phase absorption include removal of water from hydrocarbon gases, sulfur compound from natural gas, solvents from air and other gases, and odors from air. This is from the liquid stream, and then this is from the gas stream. Okay, we continue for 12.1b, physical properties of absorbent. Many absorbents have a form, small pellets, bands, or granules with small size, and then with the larger particle being used in packet beds, porous structure, and pore volumes up to 50% of total particle volume. The absorption often occurs as a monolayer on the surface of the fine pores. However, several layers sometimes occur. Physical absorption or van der Waals absorption usually occurs between the absorbent molecules and the solid internal pore surface and is readily reversible. Okay, like a cycle of absorption. The overall absorption process consists of a series of steps in series. When the fluid is flowing fast, the particle in a fixed bed, the solute first diffuse from the bulk fluid to gross exterior surface of the particle. Then the solute diffuse inside the pore to the surface of the pore. Finally, the solute is absorbed on the surface. Absorbent. The next page. There are a number commercial absorbent. Activated carbon, silica gel, activated alumina, molecular chip zeolite, synthetic polymer, or resin. Focus for commercial absorbents is surface area, average for diameter, type material that absorbed, and then how to regenerate method. For activated carbon is organic, generally absorbed by activated carbon. So focus about the organics, maybe fluid, gas stream, or liquid stream. The second commercial absorbent is silica gel. Silica gel used to dehydrate gases and liquids and to fractionate hydrocarbons. The third, activated alumina. used mainly to dry gases and liquids. And then molecular ship zeolites. Zeolites are used for drying, dehumidification in drying, separation of hydrocarbon mixture, and many other applications. Synthetic polymer or resin, such as styrene, diphenylbenzene, used to absorb nonpolar organic from aqueous solution. Generally, the researchers utilize activated carbon because it's very cheap and easy to get, and then many resources in Indonesia from the wood. There are, you can know, this is a microcrystalline material made by thermal decomposition from wood, vegetable shell, coal, and others. This is the common. Okay, next, 12.1c equilibrium relation for absorbance. The equilibrium between the concentration of solute in the fluid phase and its concentration on the solid resembles somewhat the equilibrium solubility of gas in a liquid. From the figure 12.1.1, this is some common types of absorption isotherm. This is linear, this is Freundlich, favorable, and Langmuir, strongly favorable. This is X coordinate for C. This is Y coordinate for K. For linear, this is not common, but in dilute region it can be used to approximate data of many systems. Linear uses an equation similar to Henry laws. Okay, like exponential. Okay. Here, a linear law for a linear Kc. K is constanta determined experimentally. This is linear isotherm is not common. Yeah. And the second equation from the Freundlich isotherm, we had N. Yeah, useful for liquid. There are the Freundlich isotherm equation. So from the 12.1.2 equation, we can do a derivative from this equation. You can see this Kc, and you can do logarithmic to separate N. This is the multiple, so you can remember about the logarithmic property. If multiple is similar the plus, and then N for the degree, we can move we can move from in front of the log C. Log key and logarithmic k and this is log. Okay, so we can get from this equation to be log key, log Cn, and log key. This equation is similar if we do insert from the Microsoft Excel. Is like this equation. Maybe we have to do exercise to get more knowledge about this equation and the Langmuir isotherm. Because if you see from the equation, it is like easy to solve a problems. Okay, different leads isotherm equation correlate data for hydrocarbon gases on activated carbon. The last, the Langmuir isotherm. We have key 0. From this linear, we can get just K, and then from Leeds isotherm K and N. From the Langmuir isotherm key 0 and K. Key 0 is constant, and then we can assume there are only a fixed bed of active site available for absorption. There are only a monolayer is formed. We have to remember about the principal absorption before. Here, the absorption often occurs as a monolayer on the surface of the fine pores. Okay, remember about the principle of the absorption. Okay, from the Langmuir absorption, we know about the absorption is reversible and reaches an equilibrium condition. An absorption system for the temperature is increased. The amount absorbed by the absorbent decreases strongly. Absorption take room temperature absorption, and desorption can be attained by raising the temperature. Here, absorption, temperature increase, amount absorbed by absorbent decrease. Temperature increase with the amount absorbent and then absorption occur in room temperature. The adsorption occur in high temperature. Okay, we continue about the example. Two more to get